During 1957, giant trailers bearing large, cloaked, cylindrical objects have left California and moved across the country to the East Coast. Under the nylon security cover, being transported from factory to test area is Atlas, one of our intercontinental ballistic missiles. The people of America have been little aware of the significance of these movements. For most, as the trailers rolled over the bridges, past the farmlands and through the cities, for most people watching, this was just another tank or boiler or oil rig. Too many strange objects have passed over the highways of this country for people to wonder anymore. But during 1957, events occurred in other parts of the world that focused attention on these covered missiles. Russia announced in rapid order the test of the ICBM, the satellite Sputnik 1, then Sputnik 2. Talk of missiles to the moon and beyond became commonplace. This awareness brought mixed reactions.
Why don't they go all out on a crash program basis on these ICBMs?
I don't know. We did it when we made the atomic bomb.
We can produce all right. Trouble is, it takes us too long.
Yeah, the time between developing something and getting it out in the field is ridiculous.
Talk about a lost weekend. What happened to the 8 years between 45 and 53?
Trouble is, we don't have enough push behind this missile program.
I wonder if they ever really got one of those ICBMs off the ground down there in Florida.
I don't know, but I hear the fishing's good down there.
We're probably so bound up in red tape we can't move.
Right, we need to streamline, expedite.
Right.
You know, we'd better train some more scientists and engineers real soon, or we'll be in trouble.
I got a cousin knows a guy that works on missiles, says they're too complicated.
The trouble is, the military want to run things their way.
You know what Fred says? There must be something wrong in Denmark. Why run so many tests, he says?
Out of all the talk, one idea predominated. Is there something wrong with our ICBM program? The major part of the story on the Air Force's ballistic missile program can be told. It is time for everyone to meet an ICBM, to understand our nation's approach to this important weapon. Here is the missile being raised on its test stand at the Missile Test Center at Cape Canaveral, Florida. This is Atlas, being prepared for flight test in 1957. But why 57? Why wasn't this being done in 56 or 55 or even 54? Why are we so late? To find out why, let us go back to the closing days of World War II. We all remember the vivid reports that Vengeance Weapon Number 2, a missile that hurtled out of the skies without warning, was being used on London and Antwerp. The V-2, for its day, was a remarkable missile. It opened the door, it seemed, to a new concept in warfare. In 1946, after hostilities had ceased, a number of V-2s were brought back to the United States for study and evaluation. At the White Sands Proving Grounds, tests were conducted to learn something of its construction and potential. The score on the V-2 added up to this. It was a short-range missile of approximately 200 miles. It carried a small payload of about 3,000 pounds of high explosive. Its guidance was crude, especially if applied to longer ranges. While of value to the Germans firing the short distance from France to England and Holland, such a weapon was of little value to us in the foreseeable future. We, on the other hand, needed a long-range, high payload device. Could the V-2 be improved? Certainly, if given the benefit of sufficient research and development. But how long would this take? How big the budget? And, most importantly, what would we do in the meantime? It was soon apparent, after World War II, that relations with our former ally, Russia, could not be based on mutual understanding. Russia's counter-aim of world domination was clear-cut. To block this Russian objective, we needed a powerful aerial force in being, not one on paper or in a prototype testing stage. In short, we needed a strategic air command with the capability of striking at the heart of the USSR. So, starting in '46, we built our new bombers, our B-36s, our B-47s, then our B-52s, and on to the B-58. We had to be ready at any given minute, of any given day, of any given year. SAC met this challenge, and as has so often been stated, has been the big stick keeping peace in the world. It still remains so today. But although our main emphasis was placed on the manned strategic bomber, this does not mean that all else was forgotten. We worked on tactical missiles like the Matador, on long-range air-breathing missiles like Snark and Navajo. All of these various projects, while perhaps not sufficiently emphasized in light of today's events, did help the Air Force to understand the problems of pilotless missiles and to begin to build its operational force. Russia, in the meantime, not hampered by having to police the world, could concentrate on whatever weapon of war she desired. Since Russia did not have to worry about aggressive attack from the free world, she could jump ahead and develop weapons of the future at her discretion. This, as we now know, she did, starting as far back as 1946. During the 46 to 53 period, very little was done in examining the ICBM idea, with the exception of Project MX774. This project was a small contract with the Convair division of the General Dynamics Corporation, the same company now producing the airframes for Atlas. The MX774 can rightly be called the granddaddy of today's Atlas. It was an independent American development and not a copy of the German V-2. Tests of this vehicle were run in 1947 with very encouraging results. However, the project was canceled. So, the ICBM ready for firing today is not the result of 12 years of development. There were 8 lean years. What then of 54, 55, 56, 57? Has satisfactory progress been made once we did intensify the program?
It is the considered opinion of most missile scientists that good progress has been made. Exceptionally good when one considers the complex effort it takes to produce something as strikingly new and different as an ICBM. A missile like Atlas looks simple and clean, just a hollow shell with fuel inside, is what many people think. Actually, this hollow shell contains some 300,000 precision components.
This gleaming metallic instrument is being developed in a race against time. The Air Force plans to win by taking calculated risks based on sound technical judgment. Only once before, in the Manhattan Project, has this nation taken a comparable gamble of such billion-dollar immensity. That time, the stake was atomic energy to stop a war. This time, we aim for a ballistic missile force to keep the peace.
Fittingly, it was a gamble with nuclear energy that was one of the key factors in finally triggering off the present stepped-up ICBM program. When we achieved a breakthrough in thermonuclear or hydrogen weapons in 53-54, thinking changed overnight. Now it was possible to have a warhead of a size and weight in keeping with the overall ballistic missile concept.
We had our powerful warhead. However, to go ahead with the ICBM idea, another problem had to be solved. The missile's nose cone, which contains this tremendous explosive force, had to re-enter the atmosphere without destroying itself before reaching the target area. To understand this problem, it is necessary to review the steps involved in an ICBM operation. The missile first moves straight up under the combined thrust of all engines. At a certain distance above the Earth, it is programmed into a tilt, which aims it into a curve or arc, calculated to intersect the Earth some 5,500 miles away. After providing the initial push, the booster section disengages and falls back to Earth. The missile continues on its sustaining engine until maximum speed is attained. At this point, the nose cone containing the warhead separates and continues on its established arc to the target. During most of its flight, the nose cone is traveling above the atmosphere, but as it reaches the target area, it once again enters the air ocean. The friction of the re-entry body pushing through the thicker air at high speeds could cause the nose cone to glow red hot and then disintegrate in much the same manner as do meteors entering the outer atmosphere.
It was in 1954, then, that a committee of the nation's top scientists was formed. This was the Air Force Strategic Missiles Evaluation Committee.
We of the committee studied the problem in great detail, with the likelihood of the re-entry problem being solved and with small, high-yield warheads a possibility. We recommended a redirected, expanded, and accelerated Atlas program.
In May 1954, the Air Force accepted the recommendations of the committee and assigned Atlas as its highest priority project. In September 1955, the program was given the highest national priority by order of the President. The Air Research and Development Command established a field organization in Los Angeles, California. In operation by August of '54, this ballistic missile division has complete authority and control over all aspects of the program. Assigned to head this responsibility was Major General B.A. Schriever.
Of all the interesting facets of this program, a program which is a step toward space conquest, a program which every day takes us beyond the realm of the known, the concept closest to my heart is the idea we're using in the development operational area of this new weapons system. The core of the idea is simply this. At the same time we are developing the missile, we are working on operational actions to make it a practical, workable weapons system. Now, in the normal development, production, and operational cycle, we usually take steps in series. By that I mean we carry out a study program and then a development and test program, and then we go into mass production before we finally introduce these weapons into the operational inventory. As a result, there is a long time period between the initiation of the development program until we get a new weapon system into the operational forces. We have attempted in the ballistic missile program to greatly reduce this time period. We have done this by what we call a management philosophy of concurrency. By this I mean that we at the same time are carrying out study, development, test, production, and operational actions. By this management concept of concurrency, we believe we can greatly compress the time from the initiation of our development program until we get our first units into the operational inventory. We all must remember that in ballistic missile development, we're in the Model T stage. We are today where we were 40 years ago in aircraft development. It's a very dynamic development period. There will be many changes in the years to come. In fact, there will be many changes in the months to come. Therefore, it is extremely difficult to provide you with a completely up-to-date report of progress in our ballistic missile program. The Atlas story today covers the period ending in 1957.
Inside this division, centrally located, is a vital office, the Program Review Center. Here in this room, one can easily scan the impressive roll call of associate contractors mustered to win the fight for space supremacy. Remington Rand, General Electric, MIT, Avco, ARMA, Bell Telephone Labs, Burroughs, Martin, AC Sparkplug, Douglas, Convair, Lockheed, North American, American Machine and Foundry, Aerojet General, and these major contractors are using more than 200 subcontractors and thousands of suppliers. Contractors and Air Force and civilian research centers are not just names on strips of cardboard. They are assembly shops and laboratories and test stands, radars and computers, they are people, stone, steel, and concrete. Manufacturing plants and other facilities needed to produce a radically new thing like an ICBM mushroomed overnight. Since the ballistic missile program was accelerated in 1954, nearly $250 million have been made available for new test installations and plant expansion. For example, at Convair in San Diego, a vast plant area was cleared for pilot production of Atlas airframes. And within 1 year, cattle grazing land at nearby Sycamore Canyon was converted to a complex for captive testing of Atlas. At North American's Rocketdyne facility near Los Angeles, similar mushrooming expansion has taken place in the building of giant rocket engine test stands. Each of these are capable of withstanding 1 million pounds of thrust. At the Missile Test Center in Florida, Atlas is ready for a preliminary run-up of its engines. This Atlas is not just one big question mark. All of its major systems have been tested elsewhere with painstaking care and precision.
The Air Force, of course, has been in the testing business for some time. Aircraft are one of the prime examples of rapidly changing equipment. One thing about testing a new aircraft, however, you can continue to run flight test after flight test until it measures up to standards. Not so with an ICBM like Atlas. Once it's fired, flight tested, it's gone, and a new one takes its place on the stand.
Germany's V2 project required some 2,000 full-scale flight tests during 1944-45 to produce about 6,000 operational missiles. Granted, this was a last desperate measure on the part of Germany to produce a superweapon. Still, 2,000 flight tests are not necessarily excessive in the development of a new missile.
Since the ICBM is the most advanced, intricate, and complicated weapon system ever devised, the United States couldn't afford 2,000 full-scale operational test flights. With missiles like Atlas, a new brand of testing is indicated. Every component, every assembly, every sub-assembly, step by step, must be individually tested. As an example of this test philosophy, take the history of developing the propulsion engine. First, testing metals and shapes in indoor labs. Then, captive test of one engine. Then, tests of all engines held rigid. Next, reaction to a sustained run. Then, testing of engines mounted in the actual airframe in a captive test. Also, by the captive technique, using rocket sleds, guidance units and control systems are given strenuous tests on the ground to check on shock and vibration.
So when it comes to a flight test of an ICBM, such a test is the end result of tens of thousands of prior tests of components, assemblies, and subsystems. This, then, is Atlas today, a thing compounded out of the new gadgetry of the ballistic missile age, a giant whose vital organs have been given a thorough physical, a robot capable of obeying instructions in an almost human manner. Yet for all of this, still a machine. A machine still not ready for Air Force use until every one of its mechanical quirks and patterns of behavior are well understood and proven reliable. A horse can be judged sound as $1, but there is still the question of whether he can do the 1.25 miles. The judges in America's race to perfect an ICBM hold forth in a mass of concrete called the blockhouse, only a few hundred yards from the launch pad. This is like a consultation room for men of medicine. Here, each man is a specialist in his own right. Here, diagnosticians still feel the pulse of the patient. This man and his instrument panel watches the fuel system. This man monitors pressurization. This man can tell if telemetry checks out. Here, TV cameras relentlessly study the bird to visually find flaws. Other men at periscopes scan the launch area as another check against failure. At a central panel, the test conductor receives reports from the monitoring stations, estimates the overall situation, and controls the firing button. The countdown for today's Atlas shoot is in progress.
Minus 130. Securing lock tank. Switching to internal DC power. Minus 125. Switching telemetering to lock condition. Minus 120.
Status check. Command on internal.
Affirmative.
Telemetry and launch condition.
Affirmative.
Missile and internal DC.
Affirmative.
Pressurization complete.
Affirmative.
T-minus 60 seconds and counting.
Range safety test selector switch to arm. 60 seconds and counting. Minus 50 seconds. Minus 45. 45.
Status check. Range safety arm light on.
Right. Affirmative.
Range ready.
Ready.
Water system ready.
Affirmative.
I have a prep complete light. Locks tanking secured.
Box tanking secured.
T-minus 27 seconds and counting. All recorders and oscillographs to fast. Vernier start.
Lock star tank pressurized. Ground fuel star tank pressurized.
Come on, honey. Pick up.
Count. 10, 9, 8. Ignition. Water full flow. Main stage. 4, 3, 2, 1, 0. Plus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Let's go, honey. Keep going, baby.
Atlas is on its way. During 1957, 3 such flight tests were conducted. The first firing in June, here shown, carried Atlas up several miles. At that point, the missile veered. Tried to recover. Then fell over and plunged toward Earth. It was deliberately destroyed while still in the air. The ball of fire in the sky points up a valuable lesson. Perfecting missiles is a difficult business. The second test in September was nearly a repeat performance of the June test. Once again, Atlas left its launch platform cleanly and moved up straight and true. Again, however, there was a malfunction and the missile was destroyed. The burning gases, the mark of failure to the layman, are not necessarily the mark of failure to the scientist. He learns from failure as much as from success. In the June and September tests, 90% of the test objectives were accomplished. These tests enabled engineers to redesign Atlas for a third attempt. The last month of '57 now, and the third Atlas test. Once again, a countdown, the blast furnace roar of engines. Again, a steady release. Again, Atlas reaches for the airless ocean above the Earth, and this time makes it. The missile is doing everything expected of it. And one day soon will be a deterrent added to the Air Force's manned bomber potential for peace. Actually, the ballistic missile program puts us on the threshold of space travel. The same propulsive unit now powering Atlas could boost a lighter body like a satellite into an orbit path around distant planets like Mars or Venus. Yes, man is dreaming of horizons beyond the dimensions of Earth. What started as weapons of conflict can develop into vehicles to satisfy man's insatiable craving for an understanding of the universe in which he lives. America must be a part, a leader in this quest. The Red Bear has propelled himself into space. Let not the American eagle stand with clipped wings, bemoaning his lack of foresight.